And now there's probably 50 of those studies that have been done, and across the board, if you count the number of stem cells in people with diabetes, atherosclerosis, heart disease, liver failure, kidney failure, emphysema, Parkinson, Alzheimer's, lupus, arthritis, people with these problems all have 50% or less than the number of stem cells that you find in a healthy population of the same age. The point here is that there's a direct link between how many stem cells you have in your blood circulation and your ability to repair and age with health.
Ben Esra Çavuşoğlu. 18 yıldır ayık bir hayat yaşıyorum. Bağımlılık hastalığıyla mücadelem, beni beden ve zihin performansımı iyileştirmek, hayat kalitemi arttırmak, daha sağlıklı ve uzun yaşamak için yeni yöntemler, cihazlar ve takviye ürünler araştırmaya yönlendirdi. Bağımlılık hastalığı, biohacking ve longevity alanlarındaki kendi deneyimlerimden dünyadaki son gelişmelere, çığır açan girişimcilerden uzman akademisyenlere, yıllardır yaptığım sohbetler artık her hafta Ayık Kafa Podcast'te. Welcome to Ayık Kafa today. I have Christian Drapeau, let me say it a French way, a Canadian neuroscientist and actually Canadian-American. He is also a stem cell researcher. Welcome, Christian. I want to start with how we met. I met you first at A4M in December. If you remember, I was a bit suspicious of what was Stemregen is for, because my audience knows that I've been before introduced to stem cells, mesenchymal stem cells. I did an IV form in Panama, and I have friends here who are stem cell and exosome researchers. So when I saw a bottle of supplement, which is releasing approximately 10 million, you say, stem cell, your own stem cell, I didn't quite understand. But what happened is that since December, the last time we were together, we were in Helsinki. In this 7 months period, that was the beginning of in December, my podcast, I had the chance to speak with many biohackers, scientists, longevity experts, and everyone, like exceptionally, everyone was like, we think it's working. One biohacker, Canadian, and I know that from his podcast, I don't remember his name now. He's very suspicious of many things. He says, like, you know what? I was approaching the same way, but I realized that after my workouts, I recover much faster. Our mutual friend, Natalie Needham, she was like, this is a good product. I'm like, okay, now I have to pay more attention. And then I started reading about what you're doing. I listened to podcasts. And lastly, I listened to your lecture at Biohacking Summit. I think it was the name. I approached you like, I would like to interview you. So welcome. This is a very interesting product because, I'm going to ask you how you came to this point. But I think that in a way, it's a safer way to have a repair system that you go along in your life. Before I say more, let's ask you, because you're a neuroscientist and then suddenly you became this stem cell researcher. How did you come to this point? And actually it was one product, now there are 3 products, so I would love to listen to that story as well.
So my background is brain research. So I was working on epilepsy and memory at the Montreal Neurological Institute. And in 1995, I was hired by a company who was selling at the time, they're still selling the same product, so blue-green algae from Klamath Lake. And I was hired, so this is the beginning, and I don't know how far you go into that in this history, but that was the beginning of the Dietary Supplement Health and Education Act here in America, that basically forced companies selling products to have scientific data to support any claims that they would make. So the claims on this product was mostly anti-inflammatory, immune boosting, and most people would experience sort of an increase of mental clarity, mental energy, mood elevation. So my job was to come and identify these mechanisms of actions, active compounds, and basically document this, publish this information so that they can use the studies to back up the claims that they were making. So we very quickly identified the active compounds for these different benefits. But as I'm doing this work, I came across people who reversed, or if not reversed, significantly improved conditions like multiple sclerosis, liver failure, kidney failure, emphysema, heart disease, atherosclerosis, Parkinson, Alzheimer's. And to me, not only the extent of these benefits were quite impressive, but it was the broad variety of these benefits. From a purely physiological, scientific standpoint, what was this product doing in the body to support the liver, the pancreas, the lung, the brain, the heart, almost every part of the human body. So we did a few studies to try to dig into what it could be. We got good data, but at the end of the day, nothing that really explained what it was, until one day I came across what was, to me, the first scientific documentation of a stem cell going from the bone marrow to the brain and becoming a brain cell. Now, we go back to 2001. Stem cells are only known to be blood precursors. And of all things, my field is neuroscience. Of all things, we're told that the brain cannot regenerate. So to see a stem cell going to the brain, I thought was quite groundbreaking to me. So I went into the local medical library and I started to look at what else I could find on stem cells. I found another paper documenting stem cells going to the heart and the liver. So I thought, we really need to go back here in 2001 when none of this was known. So I thought, if stem cells can become heart, brain, and liver, why not pancreas, lung, skin, and the rest? Mm-hmm. It makes no sense that it would become those three and not the rest. So let's assume that it's a matter of time. Scientists will discover that they can become everything. That means they are the repair system of the body. So we published an article in Medical Hypotheses, the journal Medical Hypotheses, suggesting stem cells are the repair system of the body. And in the back of my mind, just like you have echinacea that supports the immune system, if you have a repair system, there has to be plants supporting that aspect of our human physiology. What if this blue-green algae was basically triggering the release of stem cells from the bone marrow? So we acquired a flow cytometer to count stem cells. We started this on ourselves at first. So we started to take the product, count stem cells before and after, and we very quickly discovered that that's how this plant was working. Mm-hmm. Basically, all my work shifted now, and that's pretty much all that I have done for the past, 23 years.
Now that you explained that, because you're the scientist, would you like to explain different type of stem cells, that what they're for, what people are using it for, different type of applications, such as, systemics or injections? Can you talk a little bit, because now you said that, it's a very new science, actually, the stem cell science.
Correct. That question has a lot of layers and we can go pretty deep. So I'll try to keep it brief and to the point.
Sure.
So let's talk about the first one so that we can toss it aside, which is embryonic stem cells. Mm-hmm. Embryonic stem cells are taken from an early 8 to 10 days old embryo, and these stem cells can basically reproduce the entire organism. So they are wild in the sense that they can do the entire organism. So because of that, they're very risky for tumor formation. So they have never really been used in treatment. They have been used politically to really charge political debates, but in reality, they've never been really used, and I don't think they will be used. But that's still somewhere into the overall language of stem cells. So embryonic stem cells, they're used in research. They're not really used in treatment. So you put them aside, then the other type of stem cells are adult stem cells, and there are many different types of adult stem cells. Umbilical cord stem cells are adult stem cells. I know the adult seems a little bit of a misnomer, but it's basically postnatal stem cells. These stem cells are the youngest stem cells, probably the most potent stem cells, so placental stem cells, umbilical cord stem cells. The only, I would say, risk or negative possibly of using these umbilical cord stem cells, number one, their number is finite. Like we cannot mass produce these stem cells. It just depends on how many births we have and systems to collect these stem cells. But it's really two issues. Like the people who do not want to do umbilical cord stem cells, it's for two reasons. One of them, umbilical cord stem cells could, when you do an extraction and people who work in that field of extraction know this very well, you never have 100% purity.
So there is no such thing that they are able to clean it or take away some sort of genetic disposition?
I'm not saying that they could not, but the point is that it's so easier to just discard these umbilical cord stem cells that may have some sort of genetic issue and just move to the next sample, and get one that tests fine. So I don't think there's a lot of effort right now to correct umbilical cord stem cells for the purpose of re-injecting them. But what I mean by purity, let's say you have 99.9% purity, that all you have is stem cell. You can still have 0.1% of other things. And by other things, I mean just human tissue, like small parts, microscopic parts of human tissues. But it's human tissue from another human being, so it's foreign tissue, so it can trigger some form of rejection. It's so small that you don't really experience it, but could it lead to some form of autoimmune problem? Right now, it has not materialized in the scientific literature. In practice, I don't think it's something that has been seen, but we have not been doing this for super long. So, but it's one of the reasons why people don't want to use umbilical cord stem cells. The other one is, what if the stem cells that you have a genetic material that can be deleterious to you later on in your life? So that was just an idea. Again, it has not really materialized. There's a lot of tests to identify genes, but we don't test for all genes. We cannot test for what we don't know. So, and that really took a whole different spin when early April 2024.
Yeah, I was going to ask that because I heard you talking about, if you would not share this, I was going to ask you about that study.
So the outcome was that they basically took a mouse and they inserted the gene, which is a human gene, to produce the famous amyloid plaque and the tangles and the cognitive dysfunction that we find in Alzheimer's, human Alzheimer's. So they inserted that in a mouse, they grew up that mouse, then they took stem cells from that mouse, injected them into a recipient mouse, and then that mouse developed Alzheimer's. So it does not yet go to human and say now the danger is great for human. That's not what I'm saying. But what I'm saying is that the concept that you could transfer genetic material that can then be deleterious to the recipient, now there is evidence that this is something that can indeed happen. But let's put that aside. Not a whole lot of this has actually transpired into the experience of all these clinics using umbilical cord. So if a risk exists, the risk is extremely small, and they are still very potent stem cells. Then the next set of stem cells that are available are adipose stem cells. Adipose stem cells are spin out from fat, a fat tissue. They are dormant stem cells. It's probably the greatest source of stem cells in terms of number, but they're quiescent.
What does that mean?
They're dormant. They just stay there. They're not mobilized. They're not like released from your fat tissue. They're just sitting there, at least as far as we know today. So you can take them out, spin them off, and because they're dormant and they do not multiply, that means that they are essentially much younger as a stem cell. If you are, let's say, 50 years old, I won't throw a number. The number is just here as an illustration. Let's say your stem cells are 20 years old. It's like they don't age as fast as the person. So that makes them younger stem cells, so sort of closer to what would be an umbilical cord stem cell. Then there's your bone marrow stem cells. These are really probably the most potent, but they're affected by age. So, and these studies were done, for example, you take a mouse, 6-month-old, 8-month-old mouse, which is sort of a middle-aged mouse, and then you trigger an injury. And then you inject stem cells from a 1-week-old mouse or stem cells from, let's say, a 18-month-old mouse, which is a really old mouse. And you will see that the repair is much more effective with young stem cells. So there's it's very well known, younger stem cells are more potent than older stem cells. So your bone marrow stem cells are older. But I want to be clear here. There's a notion that is growing right now. I've heard it so many times in podcasts. I heard Tony Robbins talking about it. That past 40 years of age, your stem cells are worthless. And this is absolutely untrue. We're having studies where we trigger the release of one's own stem cells, their own bone marrow stem cells, and we have reversed heart disease. We're reversing Parkinson. So we have a significant improvement in people who are above 65. In our studies, I would say 65 to 78 years of age. So your old stem cells are still plenty good to do work for you. So these are your bone marrow stem cells. The latest one, it's been around there in the science for about 15 years, but they're sort of newer on the marketplace, which are V cells.
Yeah, I was going to ask that because, I actually asked you about that at the conference because I keep hearing that V cell, and I asked to my friends here, and they looked into the literature and they asked around to their French scientist friend and whatnot, and they say, like, it's kind of a new name to an old knowledge in a way. That's how they said. Is it correct?
I don't know if I would say a new name as much as to say there's one name that stuck. And now it's been used more widely than the others, because it's true. The other scientists had documented the same kind of stem cells as early as 2001, 2002, but they gave it different names. Like one group has called them blastomere-like stem cells. Blastomere is the young embryo. So it's somewhere, it's almost like all these names indicate that these stem cells have embryonic-like benefits. So it makes them really the most potent stem cells in the human body. They have, some documents have shown that they can even turn into egg and spermatozoa, for example.
How do they collect that?
They are into your bloodstream. They have been found to be into your muscle. They're also into your bone marrow, but the easiest place to collect them is in your bloodstream. You know, I'm sure you've heard of the platelet-rich plasma.
Sure.
Well, platelet-rich plasma is you take your blood, you spin it, and then you have this zone where you have the accumulation of these very, very small cells, and they're platelets. Platelets have no DNA. You take them out and then you inject them in a joint or in your skin, and they have amazing regenerative properties. And it was believed that it's because that fraction also contains a lot of growth factor, which is not untrue. It also contains a lot of growth factor, but it contains those V cells. So these are very small cells, and if you use a marker for DNA, you see that they have DNA. Platelets don't have DNA. And if you use a marker for stem cells, they mark for stem cells. So they are essentially, they're very small stem cells. They are so far the most potent in the human body. They are also in a quiescent state, meaning a dormant state, and they need to be activated. When they're activated, they grow in size. They start to express a number of genes, so that you can identify them in that state. And then when they're active, then they are extremely regenerative. The newer science on this is that these stem cells have chromophore, so they have like light sensors, and it's something that I'm just starting to learn into this whole field, which I find absolutely fascinating.
Yeah, you have to explain me, what do you even mean by light sensors and stuff?
We experience, as human beings, we experience light with our eyes. And if you put light into a box and now you don't see the light anymore, then for us, as our experience, the light is not crossing that wall. But it's only the visible light to our eyes that is not crossing the wall of that box. So we basically believe that light does not pass through certain surfaces because the light that we see does not go through these surfaces. But there's a broader range of light that can penetrate surfaces. Like sunlight, for example, there's a part of the sunlight that goes through our skin as light, and it goes through our skin, and it turns out that a lot of our cells have light sensors, light receptors. And these light receptors will trigger a phenomenon in the skin. So right now, in terms of science, a lot has to do with mitochondria. But there's also documentation that has been done with stem cells and with these V cells. So there's a certain wavelength that if we shine that wavelength on these cells, it basically triggers their activation. They get into their activated states. So what a technique that has been developed that is used on the marketplace is that you take a blood sample and you simply shine those wavelengths, lights, blue lights, onto the blood, then it activates those V cells and then re-inject them into your blood. And the reason why this is becoming more and more popular is that it is so far the modality of using stem cells that is the least invasive, and therefore is not an issue with the FDA. I take your blood, I put light on it, which is oftentimes is seen as doing nothing, and then you put it back in your body. So I've done nothing to your blood, no manipulation of any kind, so the FDA is not regulating it.
So almost they can do, without obviously cleaning it, let's say, the EVO 2 machine, they take blood from one arm and they put from the other arm, instead of just putting the UV light to get rid of the whatever it's inside of the blood. But if you shine the proper light to that blood circulating, then you will receive back an activation of the V cells.
You know, it would be very, very interesting for the people who do this technology to see, even if they're not using this wavelength right now, to just add that wavelength to their process. It would be, it's interesting that you said that. I never thought of it that way. It would probably be the most potent stem cell treatment.
Wow. So tell me something though, for these V cells, let me first understand, because the other ones, I know it well. So the V cells are in your bloodstream, in your muscle, and the easiest way to reach out to them is through your blood.
Correct.
Activating it besides the light. So it's like the PRP
Correct.
method.
Correct. Some of the plants that I've studied over the years also activate them. If we take a blood sample and we count the number of V cells, and of those V cells, how many of them are of a bigger size, so are activated, and then we give somebody like the blue-green algae, the plant that I started to work with first, and then an hour later we take another blood sample, the fraction, the proportion of the cells, the V cells that are enlarged has increased by about 30%. So it's not only light that can activate them.
So then, but the V cells cannot be systemic, give it back, obviously, because you cannot take the whole blood and give it back, correct? It has to be like more localized, like the skin, the whatever area you want to treat.
They do both.
Oh, they do.
They will take your blood, expose it to the light, and then give back your blood, or spin it and isolate. Because these V cells, if you don't spin your blood, they're there in the blood. So they just basically expose your blood to the light and give you back your blood. Now, if you want to go in the skin, then you cannot just inject blood. I mean, you could, but it's a lot of liquid. So what they do is that they then spin out those platelets, and then you can activate those V cells in that platelet fraction, and then inject it in the skin or joints.
Well, that's very intriguing. But with all these said, now you came up with a product, non-invasive, and able to release what you have in a way that it's kind of locked into your bone marrow. Because first, when I asked you, I couldn't understand at A4M. Then I went next to Amitai, Young Goose, and Natalie was there. I said, I'm not understanding what it does. And they say, like, the mechanism how the supplement works is kind of unlock the system, the locked in already there stem cell released into your bloodstream. I said, okay, I can now start visualizing it. So basically with your product, there are multiple plants now. Actually, let's go back to your search for these plants, because you started with green algae, but then you started finding some other product which you mixed into Stemregen, correct?
Correct. So to your first question, it's almost like the bulk of what I'm talking about right now, because for years I just went immediately into the weeds and talking about stem cells and mechanisms of actions. And 20 years later, I realized there's one thing that has not moved on the marketplace in terms of understanding. And your experience is a very, very good example of what I've been facing for many years, is to talk about something, and if I go too directly into the weeds, it's just like, it's hard to understand. So if I take it and put that into a broader context, we see stem cells, by we, I mean the general population. We see stem cells as a treatment. You go somewhere, we just talked about it right now. Umbilical cord stem cells, fat stem cells, V cells, and how do we apply them? And so for most people, the world of stem cells, that's what it is. It's a treatment. Which kind of stem cells? What's the best source? What's the best application? And what people don't know is that they're born with stem cells in their bone marrow. They release those stem cells every single day in their lives. They're not one moment in their existence without stem cells in their own circulation. These stem cells are the exact same that you take out and put back into your blood. So it's almost like if I were to say, you don't know that you have money in a bank account, and I'm going to go and extract something from your bank account, and then I put back money into your bank account, and I see, look, now you have more money in your bank account. And you're oblivious to the fact that it was there to begin with. It's a little bit what is happening. So the bigger context of this is to realize that we have these stem cells in our body. They're there. We're born with them. We release them every day. Your ability to repair when you have an injury totally depends on how many stem cells you naturally have in your bloodstream. And if you have an injury or any kind of health problem, if we can put more stem cells in circulation, your body will utilize them to repair better. What we have not talked about yet, but it's the fact of that bone marrow that goes from red, to yellow marrow. But the point is that the number of stem cells decline in our bone marrow and in our blood as we age. So all the problem that you experience in your 50s and 60s, you did not have them in your 20s. That's because you had more stem cells. So the point here is that there's a direct link between how many stem cells you have in your blood and your body's ability to stay healthy, to regain health, and age with strength, wellness, and good health.
Yeah, you explain how the mechanism works, like when you're in the 20s and when you're in the 50s and so on and so forth, because your product specifically release the stem cell from your bone marrow. So it's worth to pay attention and talk about it.
So we're born with red marrow, which means marrow that makes red blood cells. So when you look at it, it looks red. And that red marrow slowly converts into yellow marrow, fatty marrow that does not make stem cells fairly early in life. By age 15, you've lost probably 50% of your red marrow. By age 30, you've lost about 90% of your red marrow. And it keeps going down as you age. And that is directly reflected with a decrease in the number of stem cells in circulation. So your red marrow shrinks, but it releases the same number of stem cells. But as it shrinks, that means it releases fewer and fewer stem cells. So you have fewer and fewer stem cells in circulation, so fewer stem cells available to participate to tissue repair, tissue maintenance, replacing the cells that are being lost. So that's why when you are in your 30s, at some point you get an injury and you realize you're just not repairing as well as you used to repair when you were 15, 18, and it keeps going this way. It's directly linked to how many stem cells you have in your bloodstream. And so going back to your next question, the plants. So to me, the moment we propose that stem cells were the repair system of the body, today it's something that is very well accepted, and then we discovered a plant that had an effect on stem cells, then it was obvious to me, although hypothetical still at the time, that we grew up, we evolved in symbiosis with the environment. It cannot be that there's only one plant having an effect on stem cells. Like you don't have just one plant having an effect on the immune system. So how do we find them? So I simply asked the same question of how we discovered AFA. AFA was a plant that was associated with many kind of different health benefits. So I looked at the plants that had been associated with many kinds of health benefits. So you can think immediately of like goji berry, associated with longevity, medicinal mushroom, all your adaptogens, fucoidan, things that have been associated with many kind of benefits. We looked at all of them. They all have an effect on stem cells, but they're not the stars necessarily, like the strongest one that we have found. The strongest one that I found is when I had a chance to go into remote areas of the world like Madagascar. They don't have in Madagascar Chinese medicinal mushroom, or they don't have goji berries, but they have other things locally that they use for a lot of different kinds of health issues, and specifically one species of aloe. So they have 60 some species of aloe in Madagascar, but there's only one that they use to make a product called Vahona. And they use Vahona for all kinds of health problems, for old age. So we tested it and we found it, so far, it's the strongest plants that we have. Almost like doubling the number of stem cells in circulation within 2-3 hours. Then we have sea buckthorn berry from the Tibetan plateau that has been used in Mongolian medicine, Chinese medicine, Tibetan medicine for problems of the lung, the heart, cardiovascular problems, the pancreas, to help accelerate healing of bones, burn to the skin. So when you look at the spread of those benefits, that's telling me maybe we have an effect on stem cells. So I went to the Tibetan plateau, find a farm to work with, we designed an extract, and we tested it, and it triggers the release of stem cells from the bone marrow. So I have now identified over probably like 20 plants that we have tested, 5 that are the top plants that are really the most potent at putting more stem cells in circulation. And that's what we have in Stemregen.
So you have 5 different plants. How did you decide that they're not affecting each other in a negative way? Interacting with each other, let's say.
Interaction is an extremely difficult thing to study. If you have a mouse model, it's easier. But when we started all of this, so in the early 2000s, and my big question in my mind was, I discovered all of this by observing people consuming blue-green algae. So these were people consuming blue-green algae. So I know that that benefit that we documented exists in humans, but it's not everything that transfers, between mice and humans. So am I going to have the same phenomenon in mice? I don't know. So I either start to go and develop all of this in mice and discover that it is not working in mice, or even if it works in mice, once it's all done in mice and in animals, I need to redo it in humans. So I did all of this in humans. I based all the information on humans, and it's an expensive assay to test these ingredients in humans. And it's difficult to test interactions in humans because you cannot take tissue biopsies, and so it's much more difficult. So my approach was, I worked with a small team of doctors, and they had patients, and I would send them new formulas. And they would try the product on their patients, and it's subjective. But if there is an interaction, they would come back and they would say, and that product, doesn't work as well, or I don't see as much benefits. But we had the reverse. The moment we start to blend some of these products and these ingredients together, doctors would come back and would just say, I don't know what you did, but this is working so much better now with my patients. And by working better, what they would see is that, let's say it would work in 50% of their patients, and it would take them, let's say, 6 months to get benefits. Mm-hmm. They would come back and they would say, now this is working in 75% of my patients, and I'm getting benefits in 4 months, in 3 months. And then it come back with Stemregen, you get benefits sometimes in just a few weeks. So that's the benefits.
A couple of things now I'm thinking. First of all, you trust the safety of these plants because you went to these areas that local people were already using them. Therefore, they didn't have any adverse reactions. It wasn't just some wild thing that, you don't know if it's going to poison you or not. So that's number one.
Correct. And historical use. Yeah. It's not only that they have been used, like they're documented for hundreds of years. Yeah. That's
what I was trying to say, actually. The second thing is that you were able to, you sit down and you guys literally counted your own stem cells first, like how much I'm releasing in my bloodstream, what's going on. The third is that you're not saying that, hey, take my product and you're going to heal. How you describe your work with these other doctors, saying like they were treating a patient for whatever reason, heart disease or bone fracture or liver something, but while they were adding Stemregen into their treatment plan, instead of healing in 6 months, it was reducing into, let's say, 3 months.
Correct. That was the kind of marker that they were using and we were using to document the benefit of a formula compared to another. And the other thing also that lead to this idea is that we have clear evidence, and the moment you look at the graphs of how stem cells are released and how they increase, then you really get the idea. AFA is 1 hour, it comes down, it comes up, and about 2 hours later, it's back to baseline. Sea buckthornberry, it slowly increases up to about 2 and 3 hours, it starts to go down. The allomacroclada, after 3 hours, the number of stem cells are still increasing. So you can see that we have different mechanisms of actions. On what has been documented, what we have in blue-green algae is an L-selectin blocker. What we have, for example, with notogensin, and probably the same thing with sea buckthornberry, it's what I would call like an injury-mimicking compound, a repair-mimicking compound. It kicks in a response in your body as if you had an injury, like fasting mimicking compounds, for example. So we can pick up in the blood the same compounds that you normally see when a body has an injury. So it mimics the injury without having the injury. So if you look at many things in nature, when they act through different mechanisms of action, oftentimes they work synergistically. So, and that was the impetus of blending them as we move forward.
You added few more products because when I first met you, there was only one product, the release with these 5 different plants inside. And then you were launching at Biohacking Conference in Dallas, the 2 more products, actually 3 more, but one is for sports people. So let's say 2 more products. Let me ask you first. So your own stem cell is released from the bone marrow, starts floating around, whatever, through your veins, and then decide where there is a need, like, how does it work?
The cell doesn't decide a whole lot, but what is happening is that it's inflammation. It's part of the inflammation cascade, if you want. The injured tissue is releasing one specific compound called stromal-derived factor 1 locally into the capillaries of the affected area. So when a stem cells circulate in these capillaries, that compound will bind directly with a specific receptor at the surface of stem cells, and when these two connects, that will make the stem cells express adhesion molecule, and the stem cell will cling on the capillary wall. And that whole process will trigger the migration of stem cells through the capillary wall into that tissue. And upon contact with cellular debris of that tissue, the stem cell will multiply and then transform into cells of that tissue. So that's how a cell identify where to go in the body. They follow signaling.
And you said at the beginning of the podcast, you were able to witness that they also go through the blood-brain barrier and get into the brain?
You know, you're correct. We did not observe that, but the scientific literature is fairly clear. While stem cells do not massively cross the blood-brain barrier, some of them do. They boost repair in the brain. And this, we've seen it. Like, we have cases with spinal cord lesion. We have a study on Parkinson right now that has just started around January. So we have a number of patients that have done 3 months. And after 3 months, we have in 4 patients so far. So it's very preliminary, but 50% reduction in Parkinson's symptoms, 36% reduction of depression, and 56% improvement in quality of life. The study continues, but what I mean is that we have seen benefits in many conditions touching the central nervous system just by releasing one's own stem cells. So we know that stem cells do not massively cross the blood-brain barrier, but they do to an extent. When they get into the brain, our understanding so far is that they work in a paracrine effect. So they will release exosomes, they will release growth factors that will sort of wake up the resident brain stem cells, where they migrate then to the site of the injury and they do their own internal repair.
If it's released from the bone marrow, wouldn't it just heal the bones?
This is a very interesting question because welcome to the evolution of science, okay? In the world of embryology, you know, you've got those 3 original tissue in the very, very young embryo, the endoderm, ectoderm, and mesoderm. And they all developed into different kind of systems in the body. So your bones all come from the mesoderm. And the cells in the bone are called mesenchymal stem cells because they come from the mesoderm. So the general idea through, like I would say, the dogma in science is that a cell cannot escape its fate of being of a certain lineage. So if these cells emerge from the mesoderm, they can only become tissues of the mesoderm. So they were historically known to have the ability of making blood, but also making like some bones and connective tissue and tendons and ligaments and things like, because this is all part of the mesoderm. And what we have seen right now pretty clearly throughout the scientific literature is we can pretty much throw all of this away. Stem cells coming from the mesoderm. So bone marrow stem cells can become virtually anything in the body. So it's true conceptually, it's true to the dogma. That's what the dogma used to tell us. It's not true to reality.
Your product helped the release. So tell me, why is it locked into the bone marrow again? They're
not locked. They're released at a certain pace.
Okay.
And because the red marrow shrinks, then that means the resulting number of stem cells in circulation decline as we age. But let me go into something that we didn't have a chance to talk, but I think is fundamental. So red marrow shrinks as we age, but the number of cells that we lose does not stop. If anything, it increases as we age. Wear and tear, free radical, exposure to environmental pressure, let's say. So we lose cells faster and faster. One thing that stem cell research has revealed, and we've heard this before, you have a new body every year, 7 years, every 12 years. Actually, none of these statements are correct. The correct statement, and this is now documented with data, is that every single organ and tissue goes through its own turnover rate. So you got a new skin every month, a new liver every 2-3 years, half of a new heart every 25 years. Everything is in turnover. Turnover means you lose cells and you replace them. Otherwise, it's not turnover. It's pure loss. So turnover means they're replaced. They're replaced by stem cells. So since the number of stem cells decreases as we age, there's a point where we lost the ability of fully compensating for the process of cellular loss. That's when we start to accumulate a deficit in our tissues. I believe that this is the fundamental process of aging is that one. The fact that we're losing cells in organs and tissues as we age. The speed of the development of age-related diseases depend upon the speed of the decline in the number of stem cells in circulation. So you get a 75-year-old, super healthy, running a marathon, no health problems. I bet you he naturally just has more stem cells in circulation. He's one of those that have more stem cells.
With that said, another question arises. So if the red marrow shrinks, does that mean that the production of stem cell also reduces, or there's the same amount of stem cell inside?
The production of stem cells in terms of percentage of the bone marrow probably stays constant. But because your red marrow shrinks, you end up having a lesser output of stem cells, input into the blood of stem cells. So fewer stem cells are released.
Like we get old and the mechanism also starts slowing down, therefore it's not releasing as fast as many all the time?
It could be. It has not been studied. So for now, let me just say, let's assume that the number of stem cells leaves the bone marrow at the same pace. But the fact that you have less and less red marrow, then you release fewer and fewer stem cells. So fewer and fewer stem cells are in your bloodstream, available to both repair and offset the process of cellular loss. And I'm going there because in 2013, I published this hypothesis that the decline in the number of stem cells is actually the fundamental cause of disease formation. We develop age-related diseases because we don't have the stem cells to offset that loss of cells in our tissues. And I propose there's one way to test for this. Let's go and count the number of stem cells in the bloodstream of people who have developed various kinds of age-related diseases, and we should see that they have fewer stem cells than healthy people. And now there's probably 50 of those studies that have been done, and across the board, if you count the number of stem cells in people with diabetes, atherosclerosis, heart disease, liver failure, kidney failure, emphysema, Parkinson, Alzheimer's, lupus, arthritis, the list keeps growing. People with these problems all have 50% or less than the number of stem cells that you find in a healthy population of the same age. So the point here is that there's a direct link between how many stem cells you have in your blood circulation and your ability to repair and age with health. So if I come back to your original question, they're not locked into the bone marrow. It's just that the number that you normally release simply decreases as we age because the red marrow shrinks. So if we can kick more stem cells out of the bone marrow that you're left with, then more end up in the blood. So your body sort of has the repair power that it used to have, let's say 10, 20 years ago. So that's really what we're trying to do. Just put more stem cells in circulation. And as you release these stem cells, the red marrow does not lose stem cells. Like, you're not affecting the red marrow, because when a stem cell leaves the bone marrow, its sister cell stays in the bone marrow. So your bone marrow stays constant. It shrinks, but the red marrow you have stays constant.
So let's say that you're able to run 5 miles in half hour when you're young, when you're in your 20s, but not in your 50s. With that support, because you have the muscle, you have everything, but you're not as fast. So basically your supplement is helping that bone marrow act faster, younger, in order to release the stem cells out, in a way.
Correct.
But you say it never ends, because I heard many people asking you, do we ever then, if we keep pushing these stem cells out, are we going to be ending without stem cells? Which you're saying, no, it will not happen.
No, it will not happen in the way that they asked the question. But if I answer the question from a purely scientific standpoint, I do believe that we die at some point because we run out of our ability to repair. But you die before you actually run out. So it's almost like your battery goes down and your machine is no longer working. Your battery is still not completely gone, but it's too low to maintain the whole process of life if you want. But you're not going to affect that by releasing more stem cells. So their question is, they oftentimes want to say, if I release stem cells, am I going to run out and then have a problem? The answer to that question is no. But are we passing as we age because we run out of stem cells? In a way, I think that the decrease in the number of stem cells makes you less and less capable of maintaining your tissues, and at some point you die of some form of tissue failure because your whole body doesn't have enough stem cells to maintain everything.
I had a question to you when I was at the conference. Let's take me. I don't have any known illness or organ problem. I consider myself healthy based on certain tests that I might have some systemic inflammation. But, these ready tests, with one drop of a blood, take it or leave it. I'm not so sure. What happens if a young person takes it? Will it be like, it's going to be releasing quite often new stem cells, therefore something before getting worse? It's almost like healthcare, not sick care in a way. Is that how it's working?
Correct. Well, two answers to that question. If we go back to what we just talked about before, as you age, you have fewer and fewer stem cells, so you no longer can completely offset cellular loss. What we face here is that in medicine, a disease is when you pass a certain threshold that is called a diagnosis. So we diagnose you, we say, okay, you've crossed that line, now this is considered a disease. But it didn't start on that day. Mm-hmm. It started like 10, 15 years ago. So if you put more stem cells in circulation and can help those tissue maintain themselves and replace the cells that are being lost, the problem simply does not show up later on. So you want to start into a healthcare approach where you say the health that I have today, I know that I have it because I have more stem cells today, and I'm going to lose it because I have fewer stem cells in my future. So if I start today to put more stem cells, then I keep the health that I have today. So that, to me, is the best approach. But it's an approach that is still just a minority in the population that thinks that way. Other than this, if I take your example of the runner, what the 20-year-old will see is that if he goes and he runs like really hard, like something that he knows the day after he will be sore, that means he put so much pressure on his body that he created microlesions in his muscles, ligament, tendons. These microlesions release inflammatory compounds, they call for repair, and that's the pain and the soreness that this person is experiencing. If he can put more stem cells in his circulation, and these stem cells are called to these areas to repair, he will see right away that if he puts more stem cells in circulation, the power of his own stem cells. Because that's really an area where we're pushing right now, which is athletes, sports, not necessarily like Olympic athletes, but any people who are physically active. When they do something, they get sore. So if you put more stem cells in circulation, you can see right away, like overnight, what really your stem cells can do for repair.
You have the release, you have signal, and you have mobilize. Why did you feel the need of adding more product, and what do they do?
So the release is the Stemregen that we've talked about since the beginning. It's the same exact formula, put more stem cells in circulation. It's just now called Stemregen release. The signal is for systemic inflammation. Now, let me go back into, you brought up just before that, I think it's important to dig into this a little bit. As we age, if we don't have enough stem cells to really repair well, that means we start to accumulate small areas with small damage, small lesions that don't repair well because there's not enough stem cells to repair all of them. These are all the little aches and pains that you feel when you get up in the morning, or if you do something unusual, you realize you're no longer 20. So we've all had these experiences. That's because you don't have enough stem cells. All these areas start to produce inflammatory compounds, and because you don't have enough stem cells to repair them, that inflammation doesn't stop, and slowly it accumulates systemically. In science, they call that DAMP, damage associated molecular patterns. So a bunch of areas that spew out inflammatory compounds, and because they don't repair, it becomes systemic. So I would say very common for people above 50 to have some level of systemic inflammation. Now, that systemic inflammation is now tied, I'm sure you've heard of the term inflammaging. It's associated with many kinds of health issues. But one of them, which is kind of a vicious cycle, if you want, is that it also suppresses stem cells' ability to find the place where is the problem. Because I call it, or I refer to it like background noise. It's a stupid example, but I think it makes people understand. You're in a hotel and I take an apple pie fresh out of the oven and I put it somewhere in the hotel. Go find it. Well, you walk in the hotel, you smell, and there's a point it smells more and more. You follow the smell and you find the room where there's the apple pie. That's how stem cells find an area where there's an injury to repair. Now, let me put 1,000 crushed apple on the floor of that hotel. Now I'm making it much more difficult for you to find where the apple pie is because it's smelling apple everywhere. That's your background systemic inflammation. When your inflammatory signal calling for stem cells has leaked and it's in the blood circulation, then it makes it much more difficult for stem cells to identify where they need to migrate. So you kind of deafen your stem cells to an extent. So the product signal is meant to suppress that systemic inflammation. So it's a number of plants that have all been documented to be like selective COX-2 inhibitors, 5-LOX inhibitors, bromelain to digest the inflammatory cytokines that have been produced, plants that have been documented to suppress the formation of all kinds of other inflammatory cytokines produced by site of injuries or inflammation. So it's just to suppress systemic inflammation. The product is new in the marketplace. The plants individually have all been studied. So now we're starting a study to look at the effect of the product on systemic inflammation. So I am convinced that if you start to take signal, take the bottle within a month and go back and test for your systemic inflammation, and it will have decreased significantly.
And what is this mobilize for?
What we have seen over the years, over the past 20 some years, is that you give a product like Stemregen Release to someone, and it's not everyone that is experiencing all the benefits that they would like to see. Same thing with stem cell injection. You will say 30% of the people getting a stem cell injection will tell you it was great for me. 30% will tell you it did not give me everything that I was expecting, but yes, I see benefits. And 30% will tell you I saw zero benefits. So why is it that people don't see full benefits? They release stem cells every day. Their stem cells is doing their job. Otherwise, they would not be alive today. So their stem cells is working. Why is it not working for the things for which they're taking stem cells? Same thing here with Stemregen. And my assumption here is that it's either or both. Systemic inflammation that makes stem cells, it makes it more difficult for them to find where to go. And the other thing is that the local inflammation that has now become chronic has also affected the microvasculature in that area. So the inflammation is also reducing blood flow to that area. And by blood flow, I mean a stem cell can be 20 micron, your capillary is 12 micron. So for a stem cell to be able to reach the area that needs repair, you need a lot of elements together. You need a good flexibility of the stem cell. That means good membrane fluidity, cholesterol, omega-3, a lot of things that make a good cell membrane. But from the capillary level, you need good hemodynamics, good flow of the blood. So you need to reduce fibrin levels, so nattokinase. You need, over long term, all the bioflavonoid that support the structure of capillaries, quercetin, rutin, aspiridin, gotu kola, ginkgo biloba, those kinds of plants. They're all into mobilize. Then you need to also help the dilation of these capillaries with nitric oxide. So we have nitric oxide producers in the product. And you also need to help reconstruct and rebuild the glycocalyx, which is the layer on the inside of capillaries that makes cells slick easily in capillaries. So we have polysaccharides to rebuild the glycocalyx. So with these two products, Signal and Mobilize, what we do is that we reduce the background noise so stem cells can better identify where to go, and we support capillary circulation so that they can really reach where they need to go.
My understanding is that you made a full circle for people who lean into, I want to take one brand that has everything that will help these stem cells to migrate wherever it's needed. Correct me if I'm wrong, that if, let's say, your main actually novel product is the release, that's the one that is releasing the stem cells. The other ones, one can be, if they are already taking these other molecules that you counted, like nitric oxide, bromelain, and whatnot, they would have already a seamless fluid system. So your main and most innovative product would find their way. These are very exciting and interesting. And I know that most of these products that I talk here in my podcast and guests that I take, my audience were like, you know, we really love it, but, you know, there's no way to take it to Turkey. But that's the only product so far this is going to be my 28th episode. And not always I have products, but, you know, this is the only one that we're lucky enough that we have it in Turkey.
Yes, actually, Turkey is the first market that we opened for various reasons. It just happened that way. So we've been in Turkey for a number of years.
That's wonderful. I'm going to add in the show notes the Turkish website as well as the American one because they may read more information about it. And I'm going to keep talking about it. But I think whomever is going to listen to this podcast will have a very good understanding what it does. And I'm very excited. I started to the product. I don't know what to expect. But, obviously, if I'm healthy enough that I'm going to continue to be healthy. Thank you very much, Christian, for giving your time and making this. What time is it there? 7 a.m.?
Yes, 8:30 right now.
It's 8:30 and you need to leave. You said that you had an appointment. Thank you so much. I'm sure I'll see you around at some point.
I am sure. Yeah, we have a number of events, conferences in the next few months. I'm sure we'll see you. A4M?
Definitely A4M.
Definitely. Thank you so much.
Thank you.